Okay, welcome to our today's session. We are still looking at DC machines, and to be specific here, we're looking at DC generators. And our subtopic today is short shunt wound generators. So by the end of the session, by the end of the video, you should be able to perform calculations involving short shunt wound generators without any problem. By the end of the session or by the end of the video, you should be able to perform calculations involving short shunt wound generators without any problem. That is, I can assure you that. So let's look at our example number one. And example number one says that a short shunt compound generator supplies 80 amperes at 200 volts. If the field resistance RF is 40 ohms, the series resistance RSE is 0.02 ohms, and let me separate that, and the armature resistance RA is equals to 0.04 ohms. Determine the generated EMF, or determine the EMF generated. Let's look at the solution, and we shall start by drawing the circuit diagram. And here is our circuit diagram for that problem. We have seen that RS, or the series resistance, is 0.02 ohms, and the current through that resistance is 80 amperes. We have IF, that is the current or the field current that is flowing through this resistance. And we have another current here, IA, that is flowing out of the armature winding. This is the current that is flowing out of the armature, or from the armature. And the resistance within the armature is 0.04 ohms. We have our supply voltage here, that is 200, and we have V1 here. This is the voltage that is called terminal voltage, or the voltage after, when you sum up this supply voltage here and the voltage drop here, will give you V1. That is our diagram. So let's try to look for the EMF generated in that short shunt generator. So step number one is we shall look at the voltage across the field winding, or in other words, we shall look at the voltage drop across the series resistance. We shall look at the voltage drop across the series resistance. And we know that voltage drop is given by, or voltage using Ohm's law is given by current multiplied by the resistance. We are given here the current and we have the resistance. Therefore, we can go ahead and look for the voltage drop. And our voltage drop will be given by 0.02 times 80, and it will give us 1.6 volts. That is our voltage drop. Now, let's look for the terminal voltage. Remember, I've said that the terminal voltage will be given by the supply voltage, which is 200, plus the voltage drop. I've said that V1 here will be given by supply voltage, which is 200, plus the voltage drop across this series resistance. This V1 here is what I am calling it terminal voltage. Let's look ahead, let's progress and see. Our supply voltage is 200, plus our voltage drop is 1.6. Therefore, our sum up, or our terminal voltage will be equal to 201.6 volts. That is step 1. Step 2. In step 2, we shall be looking at the field current. Just to be clear, there's no way that you can go direct to look for a EMF without looking for these steps. Remember that EMF E is given by V1 plus the voltage across the armature. EMF is given by terminal voltage plus the voltage across the armature. Therefore, we don't have these, we need these values for us to be able to look for the armature voltage. Now, let's look at the field current. How do we calculate field current? This is the field current that I'm talking about, the current that is flowing through this resistance, RF. We have V and we have R. Therefore, current using Ohm's law is given by V over R. In our case, we are using V1 over RF. That is 201.6 divided by 40. When we key in this using our calculator, we shall have 5.04 amperes. This is our current through the field resistance, or this is the field resistance current. Field current, not field resistance. This is a field current of current flowing through the field resistor component. Now, step 3. Step 3 says that we shall look for the armature current. There's an error here. This should be current, not current. That is it. Should be current. Sorry for that. And using Kirchhoff's law, let's go back to the diagram. Using Kirchhoff's law, we say that a current entering a junction is equal to the sum of the current leaving the junction. In our case here, IA is the current that's going through the junction. IF and I are going out or away from the junction. Therefore, IA will be equal to the sum of I plus IF. We already have I and we have calculated for IF. Therefore, our armature current will be given by 80 plus 5.04 amperes. And our current through the armature will be equal to 85.04 amperes. Current through the armature will be 85.04 amperes. I hope you are following closely. Let's go to step 4 and the last step. Step 4 is the step that we are going to look for the EMF generated in that machine. Let me change this to superscript. Yes, that is it. Thank you. So, EMF generated, we have said that EMF is given by the terminal voltage plus the voltage across the armature. This one we have done it several in the previous videos. You can look at the video under DC machines that is talking about EMF, mastering concept on how to calculate EMF. I have uploaded that video in the YouTube. You can as well look at that on how to calculate EMF. Now, our V1 is 201.6 volts, and our armature voltage will be given by the armature current multiplied by the armature resistance. I've said that armature armature voltage will be given by the armature current multiplied by the armature resistance, and it's here. So EMF here, this the EMF will be given by the terminal voltage plus the voltage across the armature. And our armature current we have seen is 85.04 amperes, and our armature resistance is 0.04 ohms. Therefore, we shall look at voltage across this section here. And when we multiply 85.04 by 0.04, we shall get 3.4 0.016. When you add up this, we shall get 205 volts. I have rounded off, but you can as well write the way it is. That is 106, 206 plus 3.401. The full answer is 205.0016 volts. But mine I rounded off because of 00 to a whole number, that is 205 volts. Remember, in my class, you have to do assignments to enable you to be familiar with the concept and enable you to calculate without any problem. Remember, practice makes it perfect. Exercise number 1 or assignment number 1. It says a short shunt compound generator supplies 100 amperes at 450 volts. If the field resistance is 20 ohms, the series resistance is 0.05 ohms and the armature resistance is 0.08 ohms. Determine the EMF generated. This question is not much far from what we have done. It's just, if you are keen, you can see I've just changed the values. If you follow the steps keenly, you will be in a position to get the right answer. So let's look at our second example very fast. Example number 2 says a short shunt compound generator supplies 50 amperes at 300 volts. If the field resistance is 30 ohms and the series resistance is 0.03 ohms and the armature resistance is 0.05 ohms, calculate the EMF generated, or in other words, determine the EMF generated. What have we been given? We have the load current, that is 50 amperes. We have the supply voltage, that is 300 volts. We have the field resistance as 30 ohms, the series resistance as 0.03 ohms, and the armature resistance as 0.05 ohms. Then the first step, remember we said we have to look for the voltage drop across the series resistance. After getting the voltage drop, we add with the supply voltage to get the terminal voltage V1. After doing that, you look for the field current flowing through the field resistance. After doing that, you look for the armature current. Then you'll be in a position to solve the problem now because you have everything that is required for that problem. Let's go step by step so that you may capture what I am saying. So step 1 we've said is to look for the voltage drop across the series resistance. And we've been given as the current flowing through that series resistor as 50 amperes and the resistors to be 0.03 ohms. Therefore, when you key in your calculator these values, we shall get 1.5 volts. Let's look at step 2. Step 2 says we look for the terminal voltage. How do we calculate for the terminal voltage? Using the previous diagram that I had drawn in the first example, we have seen that the terminal voltage will be given by the adding all the voltage across that uh, circuit. That is the supply voltage plus the voltage drop. And our supply voltage is 300 and our voltage drop is 1.5. Therefore, our terminal voltage will be 301.5 volts. Let's look at step 3. I believe we are together up to that point. You can as well pause the video and try to solve these practical calculations. Let's look at step 3. Step 3 says that we have to find for the field current. And field current will be given by V1, as we have seen in the first example, divided by RF. Our V1 is here, that is the terminal voltage, which is 301.5 divided by 30, our RF. When you divide this, we shall get 10.05 amperes. Let's go to step 4 and the last step. Let's go to step 4 and the last step. In step 4, we are looking at the field current. You can combine these two steps, that's why I've said the last step. After looking for the field at the armature current, we have said that in the previous example that using Kirchhoff's law, if you draw the diagram, sorry I didn't draw the diagram, but you can as well draw using the first example that we have learned. Using Kirchhoff's current law, we know that current flowing into a junction is equal to the sum of the currents leaving the junction. Let me just illustrate very fast using our diagram above. This is our diagram here. We have seen that this current, we have said that current through the armature is entering the junction, and current IF, that is the field current, is flowing out of the junction or away from the junction. And current through the load also is flowing away from the junction. Therefore, the armature current, which is going into the junction using the Kirchhoff's law, will be given by Kirchhoff's current law will be given by the current that is flowing to the load plus the current that is going through the field resistance. I believe that now it is clear. Let's go back to our uh, workspace. So armature current will be given by I plus IF. Our I is 50 plus IF we have seen is 10.05 ohms. Therefore, our armature current will be equal to 60.05 amperes. Our armature current will be equal to 60.05 amperes. Now, let's go to the final step. The final step is to calculate for the EMF generated. And remember we said in the previous video that EMF is given by the terminal voltage plus the voltage across the armature winding. I have uploaded videos of the same here, that is entitled mastering how to calculate DC that is a mastering how to calculate EMF of a DC generator. You can as well search that in the YouTube, or you just search for Agnes Tamir in the YouTube and you'll find that video. It's video number 2 under DC machines. So our terminal voltage here is 301.5 and our voltage across the armature will be given by 60. That is the current, armature current multiplied by the armature resistance. That is 60.05 times 0.05. If you multiply this, we'll get 0.25 volts. When you sum up these two voltages, we shall get 300.45 volts. I believe it's clear, but you can, if not clear, you can pause the video, try to perform it. If there is any problem, let me know in the comment section and I will address immediately. I said my class cannot end without assignment, and here goes your assignment number 2. And it says a shunt wound, a shunt, not sorry, a short shunt compound generator supplies 100 amperes and at 450 volts. If the field resistance is 20 ohms and the series resistance is 0.05 ohms and the armature resistor is 0.08 ohms, determine the EMF generated. This problem here is not difficult, it's just a matter of following the sections and the steps that we have seen earlier one by one, and you'll be in a position to look for the EMF generated. Let me just rewind the video and say that step when you should looking for EMF generated in a short shunt compound generator. Step number 1 is to look for the voltage drop across the load resistance. You look for the terminal voltage, you look for the IF, that is the field resistance, you look for the armature resistance, and now you look for the EMF generated. But remember, in an exam scenario, the examiner can assume, can change the question, whereby he can tell you to calculate for the field resistance. While in that case, if he tells you to calculate for the field resistance, it means that he has given you the field current. Are we together to that point? So you can be told to calculate for the field resistance and the EMF generated. Thank you for watching. May God bless you.